All right, we're going to solve some more trigonometric equations today. First thing I want to bring to your attention about this difference is there's no interval. So we want to get all the answers all the way from negative to positive infinity. That's a little bit more complicated than getting the answers between 0 and 2 pi. So just a slight bit because there's infinitely more answers. But there's a way of writing it without having to get writer's cramp. Second thing I want to bring to your attention about this one that makes it different is the fact that there is a 3 in front of that x inside the argument. And we don't have a sine of 3x rule on our formula sheet. We could change it to sine of x plus 2x, do some of that stuff if we wanted to. There's ways of doing this without having to go through all that trouble. Okay, so the first thing I want to bring to your attention as far as how to solve this, and this happens quite often where you get trig function of something that's not just x, trig function of half x or 2x or 10x, whatever, is that this is sine of an object equals 1. So if I just had in general sine of something, let's go with omega is equal to some number, let's say beta. Let's just say I had that going on. All I have to do to find beta is do the inverse sine of, or sorry, all I have to do to find omega is do the inverse sine of beta. Alright, that's how you do it. So that's all that's happened here. I've got sine of something equals 1. So I know that the something, which is 3x, is going to be the inverse sine of 1. And if I'm looking at my initial 0 to 2 pi interval that I usually go with, sine happens at 1 at pi over 2, right? And that's the only answer between 0 and 2 pi where it equals 1. Usually there's two answers. You know, if it's 1/2, it happens at pi over 6 and 5 pi over 6. If it's square root of 3 over 2, it happens at 2 pi over 3 and pi over 3. All right, if it's negative square root of 2 over 2, 5 pi over 4, 7 pi over 4. So you usually get two answers, but one's one of the special ones that only happens once. All right, that's what you want to do first, is find your initial answers on the interval from 0 to 2 pi. All right, we'll call that our generator of answers. All right. The other thing I want to bring to your attention here is that there, again, are infinity answers. So I have to account for that by figuring out how to get each next answer. So if you imagine, if I draw my unit circle in here, maybe, remember how the board works. There's my unit circle. All right, pi over 2 is right here, right? And that's got a sine of 1. If I go around the circle, I get to where? But the next one, next one around is going to be 5 pi over 2. The next one around is going to be 9 pi over 2, and so on. All right. So to continue getting to that same spot, I just keep adding 2 pi to that, right? So what I do here is I take my answer and I add 2 pi n, where n is an integer. That's how you get infinity answers. So again, the pi over 2 is a single answer. Adding this extra little bit here gets me infinity answers. All right. Adding 2 pi n. So if n is an integer, n could be 1 times 2 pi. 2 times 2 pi. Negative 1 times 2 pi takes me the other direction around. Gets me negative 3 pi over 2. So, you know, going either direction. So that there's infinity integers. Each one multiplied by 2 pi gets me all the answers. All right, finally, once we've gotten that far, uh-oh, that's not what I want to delete. That's what I want to delete. There we go. Once I've gotten that far, that doesn't say x equals, it says 3x equals. So the first thing you want to do is figure out what 3x equals, get the entire answer for 3x, and then you simply divide by 3. That's 3x equals numbers, so divide by 3. When it x equals pi over 6 plus 2 pi n over 3, where n is an integer. Every piece of the answer gets divided by 3, even the 2 pi n piece. And there's your infinity answers. Just to try it out, all right, let's say I've got pi divided by 6. Caitlin, pick an integer for me. Don't make it 1 or 2. Make it some like weird one.
Negative 23.
Negative 23. Caleb picked negative 23, so there's 2 times n, which is negative 23 pi over 3, plus pi over 6. If I put that answer into this, I should get 1 out. Cross my fingers. Sine of 3 times answer equals 1. It's amazing. All right, it's great when things work. All right, so, but again, that's all that you're doing is whatever n is how many times you're wrapping around. So Caleb picked negative 23. We wrapped this direction 23 times around to get back to that same spot. And again, the divided by 3 part is just because we're finding x, it gets tripled, so it gets you back to here. When then you sign that, you get to 1. So again, sign equals number. Don't focus on the argument, focus on the structure. Trig function of something equals number, inverse trig function equals answer, and then if that answer is for something that isn't x, then you have to divide it, the final step. For infinite answers, you got to do it that way. Okay. If you got to a point where there were 2 answers, let me just throw one at you real quick. Suppose it says cosine of 4x equals 1/2. All right. And then 4x is going to be the inverse cosine of 1/2. 1/2 is one of those special numbers on our sheet. It equals 1/2 at pi over 3, and again at 5 pi over 3. Okay. Find each initial answer on the 0 to 2 pi region, and then you add your 2 pi n, where n is an integer. And then you got to divide both those answers by 4. So x equals pi over 12 plus, it'll be pi n over 2, where n is an integer. And x is going to equal 5 pi over 12 plus pi n over 2, where n is an integer. Right. The only one that's different as far as this is concerned to get infinite answers is tangent and cotangent. The tangent and cotangent goes up pi at a time. So if you get an answer for tangent or cotangent, say you get an answer here, add pi, you'll get one down there. Add pi, you get back to here, add pi, you get back to there. It just kind of keeps on flipping around like that. So instead of finding 2 answers for tangent and cotangent, find an answer, add pi n. If you want to find 2 different answers and add 2 pi n, do the same thing. You're welcome to do that. Just you're being redundant a little bit. But, that is possible too. You're allowed to do